Alright, so welcome back to another video, guys. In today's video, we will delve further into modeling. In the previous videos, we have covered basics of simple and multiple linear regression models. Now in this assignment as well, we will be using German graded dataset. So without further ado, let's get straight into the question 1 of our assignment. That says, compute variance inflation factor for the numeric predictors, which means for the predictors that are not categorical or that are not coded as 0, 1. Now obviously we will have to exclude the dependent variable, that is amount. And then if you see high VIF, then redo regression by dropping variables with high VIF. So we will start by reading our dataset using the read.csv function and then store it in the variable German_credit. After that, we will take a sample of 1000 observations. So first we will set the seed as shown here. And then we will use the sample function as we did earlier. So the first argument is 1 to 1000, a series of numbers from which the sample is to be generated. Then we will mention the sample size as 1000. So the only change here is that we are generating a sample of 1000 observations from a series of numbers from 1 to 1000. And then we will also keep the replacement as true, which is our default setting. We can use the output of the sample function to subset the German credit data, which is stored in German_credit variable. And then we will use the data.frame function to convert the output into the data frame. All this will be stored in the variable sample_ger. So this way we have created a sample data. Now after taking the sample, we will subset the numeric variables from our sample data like we did earlier. So here we will use sapply function. So we will write sapply. The first argument will be our sample data, which is stored in sample_ger. And the second argument will be is.numeric, which will check whether the particular observation is numeric or not. So here sapply will return a vector of true and false, and we will use this vector to subset our sample data. And then we will store it in the variable German_num. Now this German_num variable contains only the numeric observation of our sample data. After this, we will create a training and test split. We did this in the last assignment as well. So here we are storing 80% of our observation into training data, and rest of the 20% will be our test data. So I will not explain this code as we have already done this in the previous assignment. Now after creating training and test data, we can move on to the next step. Now the next step is to calculate the VIF. So for calculating VIF, we will use a package USDM_in_R, which has the VIF function. So we will first install this package using the install.packages function. Now I have already installed it, so I have put a hashtag sign before install.packages function. After installing the package, we can call the library USDM. You will get all these warning signs. Don't worry about it. You can just ignore them. Now after calling the library, we will just write VIF, give the first argument which will be our data. So here we are using our training data. And then we'll just run this function and it will calculate VIF. We will store the output in the variable VIF. And then we'll print the results as shown here. Now we will refer to the explanation to understand the output. So the explanation given here says, as it is clear from the above results that VIF for all the numeric variable is less than 5, that is the critical VIF value, Thus, we conclude that there is no multicollinearity between the dependent variable. So that is how you interpret the results of VIF. Now moving on to the next question, question 2. It says use plot LM function to view residual diagnostics and see if the residuals are normal. So first we will create a regression model using LM function, and then we will find out the regression diagnostics. We will see what regression diagnostics are. Now first let's regress amount onto duration and age. So we will write amount, which is our response variable, a tilde sign, then the predictor variables, which are duration and age. After that we will write the name of the dataset, which is trg underscore German underscore num. We will run this and we will store our model in a variable called reg underscore amt. After that we will use plot function to plot the model. So we can either give the reg underscore amount variable as the argument, or we can even write lm bracket open reg underscore amount as the argument for the plot. Both are same. Then the next argument for the plot is which is equal to 2. This means we need the second plot. There are up to 6 plots for the model for diagnostics which can be plotted here. It includes residual versus fitted values, QQ plot, Cook's distance, etc. Right now our objective is to check the normality of the data, so we will only plot QQ plot, which is the second plot. And then we mentioned QQ line is true. QQ line function is a function which adds a line to your normal QQ plot. This line makes it a lot easier to evaluate whether you see a clear deviation from normality or not. The closer all points lie to the line, the closer the distribution of your sample comes to normal distribution. Now we will run this function, and here we have our plot. Now we will go to the explanation section to understand it better. So point 1 says we can also generate these plots using QQplot and QQline commands. QQplot are the quantile plots used to check data normality, and we have already discussed what QQline is, so I am skipping it. Now as you can see in the QQ plot, we can conclude that most of the data points do not lie well along the line, and hence it cannot be considered normal. So what is the solution? We will have to perform transformation. We will see it later on. Now we can move to the next question. Question 3 says, plot residual versus the dependent variable for the model you built. Then do you notice any heteroskedasticity? If so, do you think there is a correction using any suitable transformation? Now you may recall what is heteroskedasticity. Firstly, it is very difficult to pronounce, so I am sure you remember this. So heteroskedasticity means unequal scatter. In regression analysis, we talk about heteroskedasticity in the context of the residuals or the error term. This is a problem because OLS, which is ordinary least square method, assumes that the population has a constant variance or heteroskedasticity. So we will use plot function to plot between the fitted values and the residuals. Now as you can see, the first argument would be the fitted values of our model, which can be extracted using the fitted function with our model, which is stored in reg underscore amt. Now the second argument, that is y-axis, would be residuals. We can use residuals function with our model to extract residual values. After this, we will run this function and our plot is ready. Now we can see from the plot, there is a funnel shape which is being formed. Hence, heteroskedasticity is present. So we will have to perform transformation now. Again, the explanation is given here. As I said earlier, I have included explanation at most of the places, so that if you don't get any topic, you can refer to it later on and can understand it better. Okay, so let's do the transformation of residuals and then we will check the heteroskedasticity again. So for transforming, we can inverse the residuals as shown here and then plot it again. Now as you can see in the plot, the variance has reduced. This means our transformation has reduced the heteroskedasticity. You can even use other transformations such as log transformation or polynomial transformation, etc. Okay, so now moving on to the next question, which requires us to detect outliers in the model. So we will use influence.measure function and we will give our model as the argument, which is stored in reg_amount. And then to check the summary of the output of influence.measure function, we will use summary function. We will store this in a variable called OUT. And here we can see we have our results printed. Now let's read the explanation to understand the results. First point says, for linear regression models, there is a class of statistics that is called deletion diagnostic or leave one out statistics. These observation-wise statistics address the question, if I delete the ith observation and refit the model, what happens to the statistics for the model? Influence.measure is used to perform regression diagnostics and returns many statistics like the DF-beta statistics. The DF-beta statistics are statistics that indicate the effect that deleting each observation has on the estimates for the regression coefficients. So if we go back to our results, we can see the DF-beta statistics are listed here. Then we have DF fits and Cook's distance. DF fits and Cook's distance indicate the effect that deleting each observation has on the predicted values of the model. Now again we will go back to our results. And here we have our DF fit statistics. And then we have Cook's distance. So DF beta indicate the impact on the regression coefficients and DF fits and Cook's distance indicate the effect on the predicted values of the model. And then we have COV ratio statistics, which indicates the effect that deleting each observation has on the variance covariance matrix of the estimates. So once again we'll go back to our results. And we can see our statistic is listed here. So in the conclusion, as you see, if any observation is influential as per any of the statistic, then a star is marked on the value of the statistic. In the first column, you will find different observations listed. So out of the 1000 observations, only these observations are influential. And based on which statistic they are influential, there is a star marked against that statistic. For example, the first observation, which is 739, is influential because of the COV.ratio statistic. Then we have 888 observation, which is influential because of the DF fit statistic, and so on. So that was all about influence.measure function in R. Now if you wish to know more about this function, then you can read more about it on internet. Now we will move to the next question. Next question, which is question 5, it says, drop observations that are considered outliers in data and rerun the LM model. So we can simply subset our data frame, which is stored in German_num, by using the output of influence.measure function, which we have calculated in the previous question and had stored in the variable OUT. So we will take out the row names of the OUT variable and then convert it into numeric form. It's always good to convert any extracted value into numeric form if you need the data in numeric form, because it is being extracted from an output, so it may not be in the numeric form. And we will use a minus sign here to tell the subset function that we need to drop these values. We will run this and we will store it in a variable called out_rm. Now as the question says, rerun the LM model. So we will again split the data into two parts, training data and test data. So our data after dropping the outlier is stored in out_rm. So we will use this data frame and subset it using the trg variable that we had created initially. So this way we will create a training and test data as shown here. Now after creating the training and test data, we will rerun the linear regression model. We will regress amount onto duration plus age, and the second argument would be the data. So our new training data is stored in trg_german_num_new. We will run this and we will store it in a variable called reg_amt_new. So that is how our model will be created. After this, we will use the summary function to check the summary of our model. So as you can see, the summary is printed here. Now we can print the earlier summary as well using the summary function and the earlier model that we had created and stored it in the variable called reg_amount. Now if you compare the two summaries, we can see that after removing the outliers, R square has improved. Earlier the R square was 37% and now R square has improved to 41%. However, this is not the end of the story. So when you create a model, there are so many factors that impact your model, and we have to fine-tune many aspects before finalizing our model. That is the reason model building is said to be an art. We learn it through experience. So you can't just read a book and start creating working models. There's a lot that goes behind creating a successful model. But don't worry, these are the first steps for you in creating successful models. Now that is all from this assignment. Let's quickly revise what we have covered in this assignment. We started by calculating VIF. Then we dig into regression diagnostics. We saw QQ plots, also check the heteroskedasticity and how you can transform the data to address this problem. Then we also discussed about influence.measure function, an important technique to identify influential points via leave one out diagnostics. And finally, we compared the two models with and without outliers. So I hope you are finding it interesting as we are picking up traction over new concepts. So stay tuned. I'll see you in the next video. Until next time, take care.